When you think of the term chemistry, what exactly do you think of? And chemistry is actually a very old science. Now, it hasn't always been known as chemistry per se, but it is something that people have been very interested in. And in ancient Egypt, they used, I'm probably going to mispronounce this, chemia, I believe. And it was basically, that's where they were studying embalming the dead, which was used for pharaohs and all that kind of stuff. And later on, they extended this area of thought into metallurgy, so using metals and stuff to create their things, which is kind of cool. Now, chemistry, because it started, in my opinion anyway, as something that was used for dead people, for embalming the dead, kind of was always seen as a cult. And I think that has kind of followed chemistry into the modern day, because sometimes chemistry is seen as weird and strange and stuff like that. But honestly, it's a really cool field. Okay, so just hang tight with me and we will check this out. But chemistry is something that's been around for a long time, and we're continuing to learn about it even today. Chemistry itself is the scientific study of the properties and behavior of matter and energy. All right. So when it comes down to what a current definition of chemistry is, I would say that chemists are just really interested in how matter behaves, what you can do with it, how you get it there in the first place. And in addition to matter, energy is actually a big part of it too. Chemistry is a physical science. All right. And a physical science, which also includes things like physics, some engineering, stuff like that, very heavy into measurement units, energy, stuff like that. So we will sometimes reach over into physics a little bit for some of our information, but most of the time, of course, it'll be just on chemistry.
Chemistry is the science of matter, of its properties, and of its transformations. All matter is made from about 100 elemental forms, the elements. Intrinsic to matter is energy. The waves of the ocean are energy made manifest and obvious. But energy permeates even the most subtle interactions of matter and is fundamental to chemistry.
Notice in the video there how they said that all matter is made up of about 100 elements, which is about right. There's 118 elements right now, and you can think of elements as like the building blocks of all other compounds, everything that you know and see around you. So if you had some coffee, perhaps, that's chemistry. If you use a cell phone, that's definitely chemistry. So those 100 plus elements, those 100 plus building blocks are really important to everything that we have to study in chemistry. Now, chemistry, as I said, has been studied by thousands of years. It started in Egypt, arguably, with the chemia, and then it has transformed over time into many different things. So there's an Arabic version, al-chemia, then alchemy is where, of course, maybe you've heard of. That's where people were trying to transform things into gold, more or less. In 1661, Boyle, who was considered a chemist, created a book called Chemistry, where he used a Y in there, but I won't hold that against him. And then, of course, chemistry is important too. Now, for a long time, chemistry was dominated by the idea that there's only 4 elements: earth, water, air, and fire. And that silly little periodic table in the left-hand corner there is kind of part of it. That's Aristotle and his group from ancient Greek. And that's too bad, because that theory really dominated science for a long time, and it was only relatively recent, well, 500 years, I guess that's not really recent, but you get the idea, that anyway, people started to break away from that. And of course, that's good, because there's a lot more to do than just earth, air, fire, and water. Chemistry is sometimes referred to as the central science because it connects with so many different fields. And in that picture right there, you can see how chemistry is part of chemical physics within physics itself. It's also connected to chemical engineering, which is big. Definitely biochemistry and biology and medicine, of course, are connected. All the environmental things. Food science, so important, of course. Geology, geochemistry, and even mathematics, computer science have connections to chemistry as well. So chemistry is a lot of times seen as a doorway that you pass through. And once you pass through it, all these other areas are open. So you may take chemistry and not do a lot of chemistry in your future. And that's totally fine, by the way. I want you to find your own path, all that jazz. But anyway, just realize that you definitely have a lot more options upon taking and hopefully understanding chemistry. Now, the major types of chemistry that chemists use are, there's basically 4 or 5 of them. But the biggest ones, in my opinion, are organic chemistry and inorganic chemistry. Now, organic chemistry you may have heard of before. It's usually a full year, second year chemistry class. So after the Chem 221 through Chem 223 series, you might take the organic chemistry series. But organic chemistry basically just focuses on carbon, nitrogen, oxygen, hydrogen, and a couple other elements. So not a lot of them, but there's a lot of use of those elements. That's where all of the pharmaceuticals come from, medicines come from, our bodies mostly use those and stuff. So it's a pretty important field. Now, I personally am an inorganic chemist. I was focused more on metals, but really inorganic chemistry is about everything that's not carbon. And there's a lot of elements. I said there's more than 100 of them. So if you cut out the 4 or 5 that are part of organic, there's a lot of chemistry in there. A lot of things left to be explored. Now, inorganic chemists may not have the uses always that organic chemistry has. Like organic chemistry, you're trying to solve, cancer drugs and stuff like that. However, there are a lot of uses, and I'll tell you, as we'll see in a later lecture, colors in inorganic chemistry are much cooler than organic, and we'll talk about that more later. But if you like color, inorganic chemistry is for you. Now, in addition to those kind, analytical chemistry, very important. Analytical chemistry is a type of chemistry that talks about how much and what kind of stuff you have in a sample. It uses often what's called spectroscopy, which we'll talk about later. That's basically light as an analysis tool. If you're a fan of CSI kind of shows, they're always using analytical chemistry techniques to figure out what's in the blood, what the poison was, and stuff like that. Now, physical chemistry is also very important, though. Physical chemistry is where chemistry, physics, and even calculus converge. So it's a pretty heavy kind of a field. But in this, then you get ways to figure out how gases behave. You can model them using math and stuff like that. It's a powerful field. There aren't very many physical chemists, but the ones that are there are really important. And a lot of the things we're going to talk about in this class come from the studies of physical scientists. Now, the newest kid on the block is biochemistry or biochemical chemistry, and that's where biology and chemistry converge, and this is becoming a huge field. Definitely, this is really, really important. It's basically the chemistry of life and how things function, and everybody needs to understand more about how the body works. Biochemists, and in cooperation with medical people and biologists, are really good about analyzing these things, so it's a really cool field. We use chemistry every day. You're using it right now because you're breathing. Hopefully, anyway. Wake up. No, I'm just joking. Okay, prof hat back on. I'll say that once in a while when I'm saying something really stupid, so apologies. All right, back to your regular scheduled programming. So we use chemistry every day. Breathing, definitely that's chemistry. Eating food, digesting it and stuff, that's chemistry. Plastic is really used a lot around us, for better or worse. We'll talk about that more later too. But plastic is everywhere. Like right now I have kind of a remote control here that I'm using while I'm recording this. That's got plastic in it, and you can probably see plastic things around you, so that's important. But number one probably in your world, and mine anyway, is a cell phone. And cell phones, wow, they have so many different elements inside them. It's just crazy. The batteries, that's chemistry. The pieces inside that make the electrons flow so that you see things on the screen, that's chemistry. The components of the case, I mean, it's just everything about it. So obviously, chemistry is important. Let's talk more about it and see if we can figure out then how this all puts together, how it all comes together to make something like a cell phone, which is pretty cool.